For this Projectile Motion Lab, you're going to investigate how does that angle of launch, given by an angle indicator on a projectile motion launcher, affect the range that a projectile will travel. So before we even get started, let's take a look at the projectile motion launcher. Let me actually bring it up a little bit closer to where maybe you can see it here. Parts of this projectile motion launcher, you have an angle indicator, and as you turn it here, the angle, as you increase the angle angle indicator obviously is going to end up increasing. You're going to end up loading one of two balls, one of two projectiles on there. There's a steel projectile, and then there's also an aluminum projectile, both that have a little hole in. Now, note that the aluminum projectile is much lighter. Now, whenever you load one of these onto the projectile motion launcher, you're just going to align the little hole to go over the projectile motion launcher there, and you're going to press back. Notice the spring here, and then there's a catch bar. So you're going to press it back. Now, sometimes, depending upon the projectile motion launcher, which lab station it's on, the catch bar is on top, and so gravity will pull it down. In this case, the catch bar is on bottom, and so I'm actually going to have to push up to get the catch bar to lock behind. I'm going to take the projectile off to demonstrate firing. In this case, whenever you want to fire, all you have to do is push the catch bar either down or up so that it releases this pin. If you need to change how fast the projectile is going, maybe it's launching too far, you simply take this bottom nut on the catch bar and you screw it to where you won't end up pressing it back as far. If you notice that it's shooting too far, then you would do simply the other. You would screw this so that it would end up actually compressing even more so that it would launch even further. Now that we've gone over that, how to change the angle. There is also a little nut on the very back of this thing right here. It's called a wing nut that you can tighten and loosen. So for me, it's on the very back right here in front of my on my lab station right back here. So you can loosen it and then adjust your angle to whatever angle you have chosen, because you're going to end up choosing 5 angles for this lab. Don't choose 0 degrees. If you end up choosing 0 degrees, then it's not really going to go anywhere. Likewise, don't choose 90 degrees. It's not really going to go anywhere. Choose angles probably somewhere between more than likely 20 and maybe up to 70. 70 might even be too steep. You might not actually get any range. You might hit the projectile motion launcher. So get the angle that you have chosen there, maybe 30 degrees. Well, let's get a 30 degrees according to my angle indicator, and then tighten the wing nut back down in the very back. Load your projectile motion. Once the projectile is loaded and you've got it locked behind with your with the screw set on the lock bar at whatever displacement you want. Obviously, you're going to want to keep that the same, because if you end up screwing it back or you end up pushing it forward at some point in time, then that's going to end up causing the projectile to go further or not as far, which isn't the point of the lab. Remember, we are looking at how does the angle affect the range. Set out some meter sticks right from the projectile motion launcher back where it's compressed, which is about the back of the part that's clamped on to the lab station. Have a lab partner make sure that they catch the projectile. Also have another lab partner put their finger down next to the meter stick wherever the projectile lands. It's good to make sure that you have the meter sticks at least mostly in line with the projectile motion launcher. That way you can actually see the direct line distance. So whenever you're ready, you just simply pull it up and it fires. Your lab partner puts their finger down wherever it lands. You record that distance in meters. If you choose to do in centimeters, it's okay. These are all direct measurements. And then you do that 4 more times for a total of 5 repetitions, and then you change to whatever your next angle is, and you continue to repeat.